Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of orthographic projection of lines. Coming to the problem statement, the front view of the line AB is 50 degrees inclined to the XY line and measures 55 mm long, while its top view is 60 degrees inclined to the XY line. If end A is 10 mm above HP and 15 mm in front of VP, draw its projections, find its true length and inclinations of the line with HP and VP. So analyzing the problem statement reveals us that the front view of the line is given, which is 55 mm long. That is A dash and B dash. And the apparent inclination with respect to the XY line is 50 degrees. That is the value of alpha. The top view makes an angle of 60 degrees with respect to the XY line. So this angle given to us is the beta. So in this problem, the data that is given to us is the values of alpha and beta, that is the apparent inclinations are given, and also the measurement of the apparent length of the line in its front view is given, which is 55 mm long. So also the distance of the endpoint A, which is 10 mm above HP and 15 mm in front of VP, is also given. So with this data, we need to find out the true length and the true inclinations of the line with respect to HP and VP. So now we shall see how to proceed with the problem. So we'll begin with selecting the line option from the sketching window and drawing the XY line of thickness 0.18 mm. So we'll draw a line of thickness 0.18 mm and annotate this line as X and Y, and also the reference planes as VP, that is above the XY line, and the horizontal plane which is below the XY line. So now using this line option again, but a projector line of 0.13 thickness, we will represent the front and the top views of the endpoint A which is given to us. So the endpoint A is 10 mm above HP. So we'll be recording the front view of the endpoint A at a distance of 10 mm. And also we will record the top view of the line of the endpoint of the line A, that is 15 mm in front of VP. So now we can go for the annotation block and select the text option and annotate the front and top view of the endpoint A. So this is A dash and this is A. So from this endpoint, we shall draw the locus line of thickness 0.13. So the locus line will be a dotted line. So this is the locus of the endpoint A in the vertical and the horizontal plane. So we can annotate this as locus of A, and this is locus of A in the horizontal plane. So this is about the locus of A, which we have done. And now the endpoint B is not given to us, so we cannot proceed with that. But however, the data pertaining to the front view length is given. So he tells that the front view measures 55 mm long. So obviously the front view is recorded in the vertical plane, and also the apparent inclination with respect to the XY line is 50 degrees. So with this data in mind, we shall select the line of thickness 0.50 because it is the visible line and a continuous line. So let me draw the front view of the line, which is 55 mm in length and also making an angle of 50 degrees with respect to the XY line. So this completes the front view of the line. So let me draw the locus line of thickness 0.13 mm passing through this point, that is B dash. So this is the locus of endpoint B. So using the annotate symbol, let me annotate the endpoint as B prime or B dash, and this particular line as locus of B in the vertical plane. So B1 dash will also be somewhere on this line, so we need to look at where it is. Okay. So now the next step is, we do know that if I draw a projector line from the endpoint, that is B dash, downwards. Okay, so let me draw a projector line of any arbitrary length downwards. Okay, so the top view of this point, endpoint B dash, that is B, will also lie somewhere on this projector line. but however, he has given me the apparent inclination which is 60 degrees. So what I can do is I can just draw a visible line, that is the apparent length of the line AB, that is in the top view at an angle of 60 degrees minus 60. So I'm going to fix the angle and then draw the line in such a way that it is going to intersect this perpendicular uh, projector line that I've drawn from the endpoint B prime. So this is where it is intersecting. So you can just see that the angle is fixed minus 60 degrees. So I can just draw a line which is going to intersect this perpendicular line. So I'll be using the trim option and trim this part. So now this is the top view of the point B. So I'll annotate this as B, and let me draw the locus line passing through the top view of the line AB. So here this is the locus of B in the horizontal plane. So I'll annotate this line as locus of, using the smart dimension, I can measure this distance of the endpoint A in the top and the front positions, and then also the apparent length of the line which was given to us in the problem statement, that is 55 degrees, and also this is the apparent length of the line in the top view, so that is around 70.7 mm. Also let us measure the angle. So the angle is 50 degrees given in the problem statement, and again this is also given to us, that is 60 degrees. So this is the value of beta and this is the value of alpha. So theta and phi we need to find out. So now we have done the this part of the problem completes the marking of the front and the top views of the line AB. So the apparent length and the apparent inclinations is given. So now using this data, we need to find out what is the true length of the line. So what is the procedure to record the true length? So earlier, if the true length was given, we used to draw a perpendicular bisector or the perpendicular projector from that endpoint to intersect or make it parallel to the XY line intersecting the locus of A in the HP, record the top view of that particular line, and then cut an arc. So using the same procedure, what I can do is I can select the arc by center point, select the continuous line of thickness 0.13. So keeping this particular length, that is 55 mm, I can just cut an arc. And then I will drop a perpendicular from this particular point to intersect the locus of B. And then from the endpoint A, I'll intersect this point. So this is the true length of the line AB. So this is B2. And this particular point will be A dash B2 dash. I'm just doing the reverse procedure. So earlier if the true length was given, I used to mark this and then take the projector from this direction and mark the front view of this true length, that is AB2, as AB2 dash, A dash B2 dash, and then complete the problem. So here I've done the reverse procedure. So the next step is, again I'll be selecting the arc by center point, select the radii of the arc as this AB, and then cut an arc until it is intersecting the locus of A in the horizontal plane. And then from that point, to the end point of the arc, I will be drawing a line perpendicular until it is intersecting the locus of A in the vertical plane. That is the locus of B in the vertical plane. So from that point of intersection, I will be drawing a line to the end point, that is A dash. So this point is B1 dash. So A dash B1 dash is the true length of the line when it is inclined to the HP at this angle. So we'll be measuring the value of theta, which is 31 degrees. And then this is the inclination of the line with respect to the VP. So that is 48 degrees. So 31 degrees and 48 degrees are the true inclinations. And the true length of the line can be measured. You can just see that this is 82.3 82.31 and this is 82.31. So we can just see that the true length of the line is equal in both the planes. So we can go for the leader symbol and then just annotate the direction of the projectors. So this is the direction in which the projector is being drawn here in this problem statement. And then this direction. So this completes the problem. So we can just annotate this as A B1, which is the top view of this particular line A B1 dash, A dash B1 dash. So with this, we have completed the problem. So here, to summarize the problem, the apparent length in the front view was given and the apparent inclination of the line in both the vertical plane and the horizontal plane was given. So keeping this data, we have constructed the projector from the front view and the top views and then arrived at getting the true length of the line AB in both the vertical plane and the horizontal plane, which is equal to 82.3 mm. So this is the problem. Thank you all for watching.